Yes, class, good morning. Today we'll discuss your problem solving of exercise 7.11. This exercise is a very important exercise. Today, the second lecture of this exercise 7.11. Question number 1 to 6 in last lecture. Today I am taking question number 7. Question number 7 same here. By using the property of the definite integrals and evaluate 0 to 1 x 1 minus x whole exponent is n. Suppose you have power here any 1, 2, 3, then you will directly solve, but here condition is different. Condition here 1 minus x की whole power n, or you have no any identity here 1 minus x whole power n. Okay, suppose you have this power is 1 minus x की power 2, then using the identity 1 minus x की power 3, then you can identity 1 minus x whole power 4, then you can identity. Here is possible to identity, but here no any identity here, then you will break. Suppose you are expand the with help of the binomial, then solve it, but integration is not possible. So how to solve it? Then you will be use your the property of this definite integrals. Yes, now start with the property of definite integrals here. F 0 to a fx dx equal to 0 to a f a minus x dx. Using this property 0 to f fx dx equal to 0 to a f a minus x. So then what result come here? 0 to a, where is the x? 1 minus x, and here 1 minus x, 1 minus 1 plus x to whole power n. So what result come? 0 to n, 1 minus x, this will be cancelled, x exponent n. Or this is the very simple, x exponent you multiply inside, x exponent, this 1 is cancelled, what is left here? X exponent n and dx. After that you will multiply the inside of this x exponent n. So what result come here? 0 to 1 x exponent n minus x n minus 1, because x exponent n into x result x exponent n plus 1. This n plus 1, not minus 1 power will be add here. This x into x exponent means x exponent n plus 1 power will be adding here. The dx, this is the very this is the easier to integrate here, because you have the x exponent and you have power here. Then using here x exponent n plus 1 upon n plus 1 minus x exponent n plus 2 upon n plus 2 and limit 0 to 1. So this is your integration. Integration of the x exponent means x exponent n plus 1 upon n plus 1, or integration of this n plus 1, then n plus 2, 1 power will be added here, n plus 2. Then using the limit here, first using the upper limit in both, 1 plus 1 n plus 1 upon n plus 1 minus 1 n plus 2 upon n plus 2. This is the upper, using the upper limit here. Then using the lower limit, when you using the lower limit, this will be the 0, always 0, because when you 0 exponent this to 0, 0 exponent this to 0, the result will come here 0. So then 1 upon n plus 1 minus 1 upon n plus 2, because 1 exponent n, 1 exponent 1 equal to 1, 1 exponent 2 equal to 1, 1 exponent n equal to also 1. So when you exponent of the any exponent of the 1, the result always comes is 1. Suppose 1 exponent is 100, then result also comes 1. So this is not changing, n या 2 and 1 and 100, this is not different. Result will be always come here the 1. So x1 exponent n plus 1, the result here come 1, or 1 exponent n plus 2, result always come here 1. Taking LCM, Taking LCM here, what result come here? N plus 2 minus n minus 1 upon n plus 1 and n plus 2. So what result come here? N, this will be cancelled, 2 minus 1 is 1. This is result come n plus 1 and n plus 2. This is your answer. After that you will taking the LCM in both, then this multiply here, then n to n cancel, 2 minus 1 is 1, so this is your final answer. According this way, when you are using the identity property here, then your question too easy to solve. Otherwise, you will directly solve then answer will be not come correct. Yes, note down it. Then next question. Yes, student, next question I am taking very important question. This question came in many times in the board exam. 0 to pi by 2, 2 log sin x minus log sin 2x dx. This question is the very important questions, and this question you will solve using the property of the definite integrals, with help of the definite integrals. First of all, you check this, here log, then you have no any identity directly, a property directly use this and you find the value of the integrals of these questions. First of all, you will be taking the property of the log, means using the property of the log in both sides, then you make it the simplest form, then find the value of the integrals. Yes, now I equal 0 to pi by 2, 2 log sin x minus log sin 2x dx. You know property log m into n. What property of n log n? According this property, suppose this n here, you can write this power in the n. Means suppose question in this form, so you will write the answer in this form. Suppose question in this form, then you write the answer in this form. Here, this 2 log, you can convert it here 0 to pi by 2 log sin square x minus log sin 2x dx. This 2 converted in this sin square x with help of this property. Second things, you have the one property of log m minus log n. What your property? Log m upon n. Log m upon n. The same thing, log m minus log n. So using this property of log, 0 to pi by 2 log sin square x upon sin 2x and dx. Yeah, otherwise you can take a mod sign. According this property, log m minus log n, this is the log m upon n. Here right, log m minus log n, log m upon n. After that, 0 to pi by 2 log sin x, you break down this sin x upon our property of 2 sin x cos x and dx. Because property of this sin 2x, what property of sin 2x? 2 sin x cos x. According this property, sin 2x break down 2 sin x cos x. This sin, this will be cancelled here. What is the left here? 0 to pi by 2 log 2, and then sin upon cos, this is the tan x by 2 dx. Means sin upon cos converting the tan x, only 2 here left, then you write is log dx. After that, using this property again, second property, 0 to pi by 2 log tan x dx minus 0 to pi by 2 log 2 dx. Again using the property of second, log m minus n, Here write in the question in this form m upon n, then you convert in this m minus n. Here write m upon n, then you m minus n log 2. Or you know log 2 here the constant. Log 2 here constant, not log x. Here only log 2. The log 2 here constant value. Then you integrate it. Here value is I equal 0 to pi. 0 to pi by 2 log 10x dx minus integration of this only at dx. Log 2 here constant, so you will integrate only dx. So here you are with your log 2 and x 0 to pi by 2. Integration of this portion only at dx. What value of the dx integration? X. And log 2 here constant. Then you can write here I equal, you convert this I1. Value I1 minus log 2 pi by 2 minus 0. So what result come here? I1 minus pi by 2 log 2. And this is your equation first. Here equation first. What value of the I1? The value of the I1 here, you will be solve this portion in the separate, and then putting the value of I1 here, then you will get the complete answer. Now I1 equal 0 to pi by 2 log 10x dx. This is the equation second. This is the equation second. This portion I am assumed there are I1. We have separately solved this portion 0 to pi by 2 log 10x dx. And I am converting this is this is the second equation. Then using the added property here, what property here? 0 to a fx dx equal to 0 to a f a minus x dx. Using this property here, now I1 equal to 0 to pi by 2 log 10 pi by 2 minus x dx. So what result come here? 0 to pi by 2 log. Using this property in the question second, what result come? Log 10 pi by 2 minus x dx. Or you know it log 10, sorry, not using log 10 90 minus theta. What value of the 10 90 minus theta? This is the first quadrant. This means result here come cot theta dx. This is the equation of the third. This is the I1. When you using the 10 90 minus theta, this is cot theta, the log cot theta. Now you will adding the equation second and third. Now adding equation second and third, this equation and this equation you will adding here. So what result get you? 2I1 equal 0 to pi by 2 log 10x plus log cot x and dx. Then you will get the result of log 0 to pi by 2, that's same here, 0 to pi by 2 and 0 to pi by 2 same here. The log 10x dx, dx taking common, log 10x plus log cot x. This is the cot x. After that 0 to pi by 2, according to this property, log m plus log n, the log m into n, log 10x into cot x. According to the property of the log m plus log n, this is the formula log m into n. Log m into n means log m plus log n. After that you calculate, note down it, then you solve the separate part. Yes, student, this you will be solving in 2I1 equal to this one 0 to pi by 2. Are here using the property are you? Which property are log m minus log n? You can write log m into n. In this property you are using here. So what result will come here? So then the 2I equal 0 to pi by 2 and log 1 dx. Log 1. You know, because tan x into cot x equal to 1. The value of the tan x into cot x equal to 1. So then log 1 and value of the log 1 equal to 0. Value of the log 1 equal to 0. Then 2I equal to 0 to pi by 2 0 dx. Our result will become 0. The value of 2I equal to 0 2I1. Then I1 equal to 0. So what result come here? The I1 here 0 in equation first. So this value will put in here 0. So the integration of the question here minus pi by 2 log 2. So yes. Now from question first in this equation, from equation first, I equal value of the I1 is 0 minus pi by 2 log 2. Result will come only pi by 2 log 2. This is your value of the integration. This is your answer. This question you will solve according this way. First of all, we are using the property of the log, then you convert in the simplest form. After that you will using the property of definite integrals, then you will be get the answer in this form. But this part you can solve this separate. This is a converted into I1, or I1 is the details of the I1, solving part of the I1 here. This is separate solving the I1 here. And this portion you have already get log 2 here constant, the integration of the x dx only x, then putting the lower limit upper limit here, then result come here this, and this converting the equation first. After that you will solving this portion, means this portion, then you get the value of this portion is I1 is 0, then you will putting the value of 0 here, then you get the answer minus pi by 2 log 2. This is your answer. Every questions in this time you will solve in this method. Yes, not on it. Yes, student, next question I am taking different type questions. This question depend on the even and odd properties. Question here, integration here given minus pi by 2 lower limit and plus pi by 2 upper limit are function here sin 7x dx. So what is the integration of this function? First of all, what is the property of the even and odd? According to this property, minus a2 plus a fx dx. Here two type functions. Which two type function here? Minus a2 plus a fx dx equal to two type function 0 to a fx dx. If a function is odd, if fx function is an even. When this function is the even, then using the condition of this, second things result will be 0 if function is an odd. When function result is come the odd, the value of the result is 0. When function is coming the even, then result coming this according to this rule. So means minus a2 plus a function this you can convert in two values, even and odd. The first of which check this the function even and odd. Yes, now fx equal to sine 7x. Suppose let value of the fx here 7 sin x, then f minus x equal to 7 minus x. What result come here? Minus 7x. Then the value of the function is minus fx. So you can say the function minus x equal to minus fx. This condition, so function minus x equal to minus fx. So then the function is an odd. Then the function is an odd. You can say is suppose this condition is implemented here is f minus x equal to minus fx, then you can say here the function is an odd function, or when function is odd then you can property of this 0. According these rules, when function is value of the odd, then result of this value of the integration of this portion is 0. So then now you can write here what result come here? Minus pi by 2 plus pi by 2 sine 7x dx. So what result of this? According this condition is function minus x, then result of negative value here 7 minus 7x. Then your result here comes 0. This is your final answer. Means integration of this portion here 0, because this function here because this function is the odd function. According this property, when those function is the odd, the result will be the 0. But then according this function is the odd function, the result of this integration is 0. So the result of this integration is 0. So this is your answer. According to this, every question, suppose in case your function is come the odd, suppose your function fx, suppose you let fx equal to cos 7x, and then you take here fx is minus x equal to cos 7 minus x, result there come always 7x. Cos minus theta equal to cos theta, cos minus theta equal to cos theta, but here sin minus theta equal to minus sin theta. This is the fourth quadrant. The fourth quadrant, cos and sec is the positive and other trigonometric ratio is the negative. So this is the fourth quadrant, cos minus theta, this is the cos theta. The fourth quadrant, cos is the positive. So then you can say here, f minus x equal to fx. So this is the positive. F minus x equal to fx, this is the positive. Or when function result becomes the positive, then integration of this portion this. Then you can integrate this. So then you can say here 0 to minus pi by 2 to plus pi by 2 cos 7x dx. You can write here 2 0 to pi cos 7x dx. Then you can easily integrate of this portion is cos 7x dx. Easily integrate, then using the limit, then you get the answer. But this function is the even function, because this is the even function. This is the even function, or this is the odd function. This is the odd function here. I mention here odd. But then when function is the even, then result of this, then you can integrate it and then you get the answer. But your function is the odd function, the result here answer. Your complete answer this. This is the second option of this. Suppose question according this way, so then how to solve it? Then you will solve according this way. Then you integrate it and then you get answer. Yes, note down it and then your last lecture today, your last lecture of the definite integral. Then after that we will start the application of the integrations. Yes, note down it.